The binomial random variable is one of our named discrete distributions. So a few things to note about the binomial. The experiment consists of n identical trials. So n being our total amount, we have n of them, n trials. We only have two possible outcomes for each of the trials, and we refer to one type as success and the other type is a mutually exclusive event that would be a failure. You either succeed or you fail. The probability of success is denoted by the letter P. And it's the same for each trial. They're all identical. I like to use an example of making free throws. So the percentage of which a person makes free throws would be converted to the probability value P. So in the event of a person making 70% of their free throws, the P would be 0.7. That percentage turned into a probability. Now the probability of a failure is going to be the letter Q, and it's going to be 1 minus P. You either make the free throw at 0.7 or miss the free throw at 0.3. There's no other possibility. The trials must be independent of each other. And our notation, we're going to use a binomial random variable. X will be our letter for that. You can use other letters if you want, but I'm going to use X. So n again is the independent trials, so we can either have 0 successes or any number of successes up to and including n. So x is going to be a number between 0 and n inclusive. Inclusive meaning we can include 0 and n. Now the mean of a binomial is pretty intuitive. The formula is n times p, the number of trials times the probability of success. So as an example, intuitively most people would know that if a person makes 70% of their free throws and they're given 10 free throws to make 10 attempts, on average they're going to make in 7 of them, or that's what we would expect them to make. They would make 7 and miss 3. Again, now that's not going to happen every time, but that's what we would expect them to do. Less intuitive is the variance. The formula for the variance is n times p times q, and that leads to the standard deviation, which is always the square root of the variance, being the square root of n times p times q. Now, some phrases that you're going to see in given problems. Anytime you're dealing with something that's using the words at least, if it's at least 4, that means it's 4 or more, so the x value is greater than or equal to 4. Other ways of say that is no less than, again, or greater than or equal to, which is something I've already used. More than or greater than doesn't include the value, so we use the strictly greater than sign. Similarly, fewer than or less than refers to strictly less than, so the less than sign. And no more than, at most, less than or equal to, all refer to less than or equal to as far as our symbol. The last one, typically the easiest one, is anytime we say the probability that it is or equals or is exactly. This would be the symbol to use. These are the only possibilities.